Hi everyone. In this lecture, we will see some applications of registers. We have already seen what is a register. We have already seen what is shift register, parallel in, parallel out register. Okay, many different type of register we have seen. What is a universal register? What is a linear feedback shift register? What is a bidirectional register? Right shift, left shift. Okay, serial in, serial out, serial in, parallel in, serial out, parallel in, parallel out. So basically, all the type of registers we have already seen. We have already seen many gate exam questions which are based on registers. Okay, so all these things we have seen. Now let's see some applications of registers. So multiple applications of registers we will see. The first application that we will see is that registers can be used to convert the parallel data into serial data. Also you can use them to convert the serial data into parallel data. Okay, so basically this is the first application. Okay, so the first application is you can use registers for parallel to serial conversion. Also you can use the registers for serial to parallel conversion. Okay, so why this is important, then we will see. So first of all, you notice that. Okay, first of all, let's see the application is that you can use the register for parallel to serial conversion. Okay, so this parallel to serial, if you have a parallel data, okay, then you can convert that data into serial data. So let's assume, okay, how to do this parallel to serial conversion? How to do this? Very simple, that you can use, basically you can, okay, using register you can do. So here you can use the parallel input serial output register. Okay, so this register we have already seen, we have already designed what is a parallel input serial output. So in this register what happens, that the data comes in parallel manner. So you can notice the data is coming in parallel. Okay, this is your data, this is your parallel data. Okay, so you can notice the data is coming in parallel, but you can notice that we are reading the data. Okay, so once this data is coming in parallel, then you can notice this data is converted into a serial stream. Okay, so here you take this is your serial out. So you can notice the data is coming in parallel. Okay, so whole, for example, these four bits are coming in parallel, but you can notice this is your register which is parallel input serial output. So this register, what it will do, it will convert this parallel data into a serial stream. Okay, so here you will get a, basically here you will get a serial stream. Okay, so this data that is coming in parallel, you have converted this data into a serial stream. Okay, so this is the idea. Now similarly you can do serial to parallel conversion. Okay, using the registers, what you can do, using the registers you can do serial to parallel conversion. Okay, how to do this? Again, here you can use, what you can do, in for this, what you can do, you can use serial input parallel output register. Okay, so this register you can use. We have already seen what is this register, how to create this register, how to implement this register, we have already seen. The idea is very simple, that you have a serial stream. Okay, so this is your serial input stream. Okay, so this is your serial input stream. Okay, so you have a serial input stream, and then what this register is serial input parallel output, means this serial input stream, this will be stored. Okay, so you can notice this serial input stream, this will be stored in this register, and now you can access this data in parallel. Okay, so you can notice this is your serial input parallel output register. So the data is inserted. When you store this data in this register, then you do this in serial manner. Okay, but you can read, once this data is here, once you have stored this data here, then you can read this data in parallel manner. So you can notice this serial input stream we have converted into parallel. Okay, so this is your serial to parallel conversion. So you can notice registers can be used for parallel to serial conversion. They can also be used for serial to parallel conversion. Now why we need this? So let me tell you why we need this conversion. Okay, so you can notice this conversion is actually important. Okay, when you have, for example, let us assume there is a computer here. Okay, this is your computer, let's assume this is your computer A, and this is a computer B. This is maybe, okay, somewhere in India, maybe this is in Bangalore, and maybe this is in New Delhi. Okay, so you can notice these are your two computers. Okay, now you can notice, let us assume I want to send some data from here to here. So from A to B I want to send some data. Now you can notice that, okay, for example, let's assume I want to send 16-bit data. Okay, so this 16-bit data you have. Okay, and this 16-bit data I want to transfer to this computer B. Now what should I do? Okay, you can notice one thing. Inside your computer, the data is actually, mostly the data is processed the data is processed in parallel manner, because you can notice in your inside your computer, if you see, there are 16-bit data bus, 32-bit data bus. Okay, so this concept you have studied in computer organization. You have 16-bit, okay, 32-bit data bus. Basically, parallelly you can access the data, okay, inside your CPU. Okay, inside your CPU you have system bus. Okay, so there is data bus. Okay, there is something called data bus. Okay, so you can notice that this data inside your CPU, you can access this data in parallel manner. Okay, similarly inside this computer also you can access this data in parallel manner. Okay, but you can notice, if I want to transfer this 16-bit data from this host, this computer to this computer, then what should I do? Should I put 16 wires? Okay, should I put like this? Okay, 16 wires. Should I put 16 wires? Okay, should I do this? No, that is stupidity. Okay, that is stupidity. Why? Because if you want to send, let us assume you want to send 64-bit data, then will you put 64 wires? Will you put 64 wires? No, you won't do that. So because you can notice device to device communication, okay, this device to device, from one device to another, this communication is done in serial manner. What it means? It means that from this computer to this computer we have single wire. Okay, so there is a single wire. Okay, there is a single wire. Now what should you do? Inside your computer you have data in parallel. So this 64-bit data you have in parallel, you are receiving this 64 data in parallel. Okay, but you want this data, you want to transfer this data on this single wire. So okay, because this is single wire, so on this single wire you have to do, okay, serial communication. Okay, so you can notice that this is your serial communication. This is your serial communication. So between the devices, between two different devices, the communication is done in serial manner. Okay, so you cannot, this 64 data you are receiving, this is your 64 data that you are receiving. Now this data you want to send on this single wire. Okay, so what you should do? Now this parallel data, what you will do, you will convert into serial stream. So using the, okay, using the parallel input serial output register. So here you have parallel input serial output register. Now using this register, what will happen? So this parallel data you have, this parallel data will be converted into serial stream, and that serial stream will be sent here. Okay, so the serial stream is going here. Now once you can reach here, now this B, what it will do, this serial stream will be converted here. What you will have, you will have serial input parallel output register. What this register will do, this input stream is coming, this input stream will be stored here. So in this register you will store this 64-bit data, and then this data you can access in parallel. Okay, so this is the simple idea. Okay, so you can notice this is that is the reason what we why we have, this is the application of registers, you can notice. Okay, because this computer B, what it can do, it will store this data. So this 64 data is coming, okay, in serial manner. This is coming one bit after. Okay, so like this data is coming, this data is coming like this. Okay, so this 16-bit data is coming like this. Okay, now this data will be stored in this register, and once this data is stored in this serial input parallel output register, then you can access this data in parallel. Okay, so this is application of, this is first application of registers. So you can do parallel to serial conversion, you can also do serial to parallel conversion. And why we need this? We need this for communication between device to device. The communication is done in serial manner. Okay, and why we do this in serial manner? Because you can notice, if you don't do this in serial manner, then between these two devices we need 64 wires we need. Okay, so 64 wires we need. So that is okay, basically that is not a good thing. Okay, so you can notice the between two devices the communication is done in serial manner. Okay, so anyway, so that is the reason this is first application of shift register. Okay, so you cannot, this is the application of shift register, this is also shift register, this is also shift register. So this is the application of shift register. What is the another application? Okay, the second application is multiplying by 2 power I and dividing by 2 power, okay, 2 power I. So you cannot, this is another application. Okay, if you want to multiply with 2, okay, so let us assume you have this data. Okay, so assume that you have 1 0 1, okay, 101. So this is your, what is this? This is 5, correct? So this you know, you already know this is 5. Okay, let us assume you want to multiply this with 2. Okay, so this is what we want to do. What we want to do, we want to do 5 into 2, we want to multiply this with 2. Okay, so basically this we want to, okay, so we want 10. Okay, if you want to multiply with 2, then what you can do, either you can use multiplier. Okay, what you can do, either you can use multiplier. Okay, so in your computer hardware there is something called multiplier. You can use this multiplier. Okay, this multiplier hardware you can use, basically this multiplier hardware, or I can say this circuit you can use. Okay, but instead of this circuit, okay, this actually multiplier, this will take many cycles. Actually this multiplier, this will take many cycles. So first of all, this will take many cycles, I can say. Okay, so this will consume many clock cycles. Okay, many clock cycles this will consume. It will take some time. Basically this multiplier, it will consume many clock cycles. Now I want to multiply this data I want to multiply with 2. So what you can do, very simple, in a single clock pulse. Okay, in a single clock pulse you can do this. Okay, so what you can do, you can just right shift this. Okay, so this data you right shift. So let's assume this is your data. Okay, so this is your data 0101. Okay, this is your data. What you do, you do simple right shift. Okay, what you do, very simple, just do right shift. Okay, just do right shift like this. Okay, just do right shift like this, and you insert 0 from here. Okay, you insert 0 from here. So what you will get after one clock pulse, remember, after one clock pulse, what you will get, after one clock pulse, this is what you are going to get. Okay, and you can note this is your 10. So in one single clock pulse you have multiplied with the 2. Okay, so how many clock pulses we need to multiply with 2? Only single clock pulse. Okay, so basically only one clock pulse is needed. Okay, in this situation only one clock pulse needed. Okay, so this is the application uh, of registers. So I can say that this right shift register, you can use this. Sorry, this is left shift register. Sorry for that. So this left shift register you can use for multiplying with 2 power k. So I can say that if you have, okay, let us assume that you have this number. Okay, so let's assume this is your data. Okay, so assume that this is your data 0 0 1. Okay, 10. So this is what, this is 6. You can note this is 6. Okay, now let us assume that I want to multiply this with the 2 power 2. Okay, I want to do multiplication with 2 power 2. Multiplication with 2 power 2 means multiply. Okay, so I can say that, okay, right shift 2 times. Okay, so what I can do, okay, for that, what you do, basically left, sorry for that, left shift 2 times. What I can do, I can do left shift 2 times. Okay, so what I can say that after 2 clock pulse, what you will get. Okay, I can say after 2 clock pulse. Okay, after 2 clock pulse. So I can say after 2 clock pulse, what will happen? After 2 clock pulse, this is what you will get. Okay, because you are doing the left shift. So after 2 clock pulse, this is what you are going to get. And what is this value? Okay, this value you can notice. Okay, so this value is I can say 24 plus 24 plus 8. So this is 32, and this is what we wanted. Okay, this is, sorry, this is a 24. So okay, so this is a 24. So you can notice this is what we wanted. Okay, so you can notice if you want to multiply with 2 power k, then that means I can say multiplication with 2 power k. If you want to do, okay, so multiplication with 2 power k. Okay, that simply means k time left shift. Okay, so I can say k time left shift. So you can notice this is the left shift register. Okay, this is the application of left shift register. Similarly, if you want to divide by 2, okay, now similarly you can notice that if you want to divide by 2 power k, then what you will do, then you will do k time right shift. Okay, so this k time right shift you can do if you want to divide by 2. So if you want to divide by 2 power I, then what you can do, you can shift. Okay, you can shift to the right. Okay, by I positions. For example, let me take, okay, so you can take the example. Consider, let's assume that this is your data. Okay, so you have 0110. This is your data. Now let us assume you want to divide by 2. This data you want to divide by 2. Then what you can do, you can do simple one right shift. Okay, just if you want to divide by 2, then you can do right shift. Okay, so just do right shift, then what will happen, so this data will be lost. Okay, this will come here, this will come here, this will come here, and from here you insert 0. Okay, so this is what you are going to get, 0011. Okay, and what this is 3. This is what we wanted, because this is 6 divided by 2, that is 3. Okay, so you can notice if you want to divide by 2 power k, then what you do, k time right shift you do. Okay, so this is another application. So what is the application? Multiplication with power of 2. Similarly, division with by power of 2. If you want to multiply by 2 power k, then you do left shift, okay, by k times, left shift k times. And if you want to divide by 2 power k, then you do right shift k times. Okay, so this is another application. Okay, what is another application? So the okay, so the third application. Okay, what is the third application? What is that? The third application is random sequence generation. This we have already seen many times. Okay, so this random sequence generation, if you want to generate random sequence, then also you can use right shift register. Okay, so this random sequence generator generation, for this you can use linear feedback shift register. I told you this is very important. So this linear feedback shift register, using this, what you can do, you can generate random sequences. Okay, random sequences you can generate. Okay, so this we have already seen on Go Classes YouTube channel. You can find it. Okay, what is this linear feedback shift register? This we have already seen many times, that this is useful, okay, in random sequence generation. Okay, what is another property? Let's see what is the another application. The another application is of basically delay. Okay, delay the pulse. Okay, delaying a pulse. Delaying a pulse, this is another application. This is application of SISO. Okay, so this is basically, this is application of serial input serial output shift register. Okay, so let us see what it means. So if you have serial input serial output register, then basically you can use this for delaying a pulse. For example, let us assume that you have 3-bit. Okay, just assume that you have 3-bit serial input serial output shift registers you have. Let's assume. Okay, so let's assume this is your shift register. Okay, now, so this is your shift register, serial input serial output shift register. Okay, this you can notice, this is our 3-bit serial input serial output register. This is your clock. Okay, so you can notice this is the input clock. Okay, so anyway, this is the system clock actually. Okay, so this is your system clock. This is your system clock. This is your external input pulse. Okay, so this is your IN. I can say this is the external input pulse, and this is your serial input serial output. So you can notice this is your serial in. Okay, so here you insert the external data, and this is your serial out. Here you can read the data. Okay, so this is DAQA, this is DBQB, and this is DCQC. Okay, so now you can notice. Okay, so this is your serial input serial output shift register, right shift register. Okay, and this is the external data, this is the external pulse. Okay, so this is the input data pulse. And now what will happen? Just think about it and tell me. Okay, this now, if this in, okay, if this data you have, let us assume this input data that you have. Okay, so you have this data. So this is your serial input serial output. Okay, let's assume this is your data, 0 1 1 1, this is 0 1. Okay, so let's assume this is your data. Okay, so this is your input data. So first you have 0, then 1, then, okay, so this is your input data. Now what will happen? What is going to happen here? So you can notice after one clock pulse, what will happen? So this is the okay, initially you can have something. Okay, so after one clock pulse, what will happen? Now this data, when it will be available here, you can notice this is serial input serial output. What it means? If you, okay, so this is a black box. Remember, this is a black box. Okay, so you can think like this. Okay, this is a black box. This is a black box. You can put this in a box. Okay, this is a black box. Now you can notice. Okay, here you are applying the input data. Okay, and then you are reading it here. Okay, so what you can see, remember, you can only see this is a black box. Inside what is happening, we don't know. Okay, so let's assume that we don't know. Okay, so okay, actually we know, but okay, just assume that this is a black box. Okay, this is a tunnel, you can think out. Okay, let's assume this is like a tunnel. Okay, just think about, this is a tunnel. Now this data you are inserting. Okay, now when this data will be available here, let us see. So when this data will be available here, this is the point, yes or no? So let's see. Now after how many clock pulse this data will be available here? Very simple, after 3 clock pulse actually this data will be available here. Okay, so this data you are inserting from this end. Now after 1 clock pulse, so this, okay, so I can say after how many clock pulses this data will be available here. I can say after how many clock pulses, the input data stream will be available at the output. So this is the question. Okay, so this input data stream, when will it be available here? Okay, so this answer, okay, so what is the answer? Answer is 3 clock pulse. After 3 clock pulse, this data will now be applicable here. Basically, you in this tunnel, you are going in this tunnel, and after how many time, after how much time you are basically getting out of this tunnel. Okay, once you get in this tunnel, okay, after how much time you are getting out of this tunnel, this is the question. Okay, so now see here. Okay, I can say that now after 1 clock pulse, what will happen? After 1 clock pulse, this is going to situation. Okay, so this is the situation after 1 clock pulse. Okay, I can say after 1 clock pulse, this is the situation 0 and so on. Okay, okay. Now after next clock pulse, what will be the situation? After next clock pulse, the situation will be, this will be 0, this will be 1. Okay, and after next clock pulse, what will be the situation? The situation will be, this here will be 0, and then this will be 1, this will be 1. Now you can notice this 0, we inserted this. Let's assume this is time t equal to 0, this is t equal to 0. Now this is time t equal to 1, this is time t equal to 2, and this is time t equal to 3. At time t equal to 3, you can notice this data that you inserted, this data is applicable, this data is available at the end. Okay, so you can notice after how many clock pulses the input data stream will be available on the output. So the answer is 3 clock pulse. So you can notice we are delaying the pulse, this input pulse we are delaying. Okay, so here I am saying this input pulse we are delaying basically. So this shift serial input serial output shift register, this is right shift register. So using this, what we can do, we can delay the pulse, we can delay the input pulse. Okay, so delaying a pulse, that you can do using serial input serial output shift register. So this is another application of a shift register. So we have seen 4 applications of shift register. Okay, one last application we will see, and that is not application, that is not application actually, that is just serial transfer. If you want to transfer data from one register to another, then how will you do? Okay, so so basically this is just serial transfer. So let us assume that this is your objective. You have this register. Let's assume this is a 4-bit register. Okay, so this is your A, B, C, D. This is a 4-bit register. And let's assume this is your another register. This is P, Q, R, S. This is another register. Okay, so let's call this register RA, and let's call this register RP. So this is your register RA. This is register RP. Let us assume you have this data here. Okay, so this is let's assume this is your data. Okay, now what we want to do, we want to copy this data in this register. This is our target. Okay, so this is our target, that we want to copy, we want to shift this data, we want to copy this data, this register data in this register. Okay, initially let us assume initially you have this data here. Okay, something here you have, but we want to copy this data into this. Okay, so how we can do this? And remember, you should not lose this data. Okay, because we are just copying this data, we are copying here. Okay, this data we want to copy here, so you should not lose this data. So how will you do this? So the answer is very simple. Okay, here what you will do, very simple, serial transfer. Okay, so our target, what is our objective? So let me write it here. Our objective is basically, okay, copy RA into RB. Okay, into RB. So this is our target. Now how to do that? Okay, if you want to do this, then what you can do, very simple, that you can use the right shift register. You can use, what you can do, let us assume this is also right shift register. Okay, so this is serial input serial output right shift register. This is also serial input serial output right shift register. So let's assume, let me give it here. So let's assume that RA comma RB. So RA comma RB, let's assume these are serial input serial output shift register. Okay, shift register. Now, okay, let's see. So here to, okay, if you want to copy this data into this, then what you can do, very simple, you can just connect this. Okay, so this output you can connect it to this input. Okay, so the output of this flip-flop, because remember here you have 4 flip-flop, this. So the output of this flip-flop, okay, you can connect it to the input of this flip-flop. Now, okay, but remember, if you do like this, then what will happen, you will lose this data. After every clock pulse you are losing this data. What will happen if you do like this? If you do this solution, then this is a wrong solution. Why? Because if you do this, then after 1 clock pulse, okay, so this is your t0, then at t1 what will happen? At t1 you can notice this data will go here. Okay, so this data will go here, 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 this will be lost. Okay, this data will go here, this data will go here, this data will go here. But you can notice, because this data is gone, so now you are losing this data. Okay, so actually some let's assume some new data is coming here. So you can notice this 0 1 0 1. Okay, after one clock pulse, you can notice after one clock pulse, this is what you are going to get. Okay, you can notice this you lost, actually. Okay, so this is not correct. Okay, why this is not correct? Okay, so this is not correct because you are losing the data. This is not correct. Why? Because ra lost. Okay, so this ra, okay, so content is lost. So what I can do, you can use like you can just think about it. The simple solution we have, simple solution is that we put this data here. Okay, we basically whatever we are taking out here, okay, whatever data we are getting it out, okay, that data we put here. Now you can notice that after 4 clock pulse, what will happen? After 4 clock pulse, we can copy this data, will be copied here. Also this data will be remain as it is here. So now you can notice what will happen after 4 clock pulse. So you can notice initially a b c d, and this is your pqrs. Okay, so initially this is your initial situation. Initially, okay, so the content of this is 1011. This is the content, and initially the content here is 0101. Now after one clock pulse, what will happen? Okay, so after clock pulse 1, I can say, so after one clock pulse, let me call it t1. Okay, so after one clock pulse, what will happen? Very simple. Every data you are shifting, so this will be basically shifted. Okay, so this will be 0. Okay, so because this is you are shift, okay, so this data will be actually shifted. Okay, and you can notice this data will be coming here, and then you can notice, okay, so this data will be coming here, this data will be coming here, this data will be coming here, and you can notice because, okay, this data you are, okay, putting it again here. Okay, so then this data you are again putting here. So what we will get? We will get 1 here. Okay, after one more clock pulse, what will happen? Very simple. Then this one again will come here. Then you have, okay, 1 1 0, and then this 1 1. Okay, and then 0, and then 1. Okay, after next clock pulse, what will happen? This 0 will come here also, this 0 will come here also. Okay, so like this 1 1 1, and then you have 1 1 and 0. Okay, after one more clock pulse, what will happen? After one more clock pulse, this one will come here, then 0, okay, 1 1, and then 1 0 1 1. Now you can notice, that's it. Okay, so you can notice after 4 clock pulses, this is your original content. So we have copied the data from register ra to rb. Now you can notice both are same, ra and rb both are same, and this is your initial content. So you can notice what we have done. We have basically copied ra into rb. Okay, so the register a content, the content of register a, we have copied into register b, and you can notice the data inside this register a is as it is. Okay, so this is how you can do the serial transfer. Okay, this is called serial transfer. If you want to do serial transfer, then this is how you can do. So I can say that after 4 clock pulse, remember, okay, how many clock pulse? After 4 clock pulse, this data, this register a data will be copied into the register b data. How many clock pulses are needed? Okay, so for that I can say 4 clock pulses are needed. Okay, so here I can say for this serial transfer, you can notice for total 4 clock pulses needed. Okay, so all the applications of shift register we have already seen. Okay, so this is your shift transfer. You can just check it out. Okay, so this is how you can do shift transfer. Okay, so these are the applications of shift register. Okay, now you can solve this question. This is a question, this is a 1996 gate question in electronics branch. Okay, so you can solve this question very easily. What this is saying? This is saying that a pulse train, okay, basically there is a pulse. Okay, there is a pulse, there is a stream, there is a data stream, I can say. So can be delayed by few, okay, clock periods using, okay, so using which register? So this we have already seen. So if you want to delay a pulse, okay, then that is a application of shift serial input serial output register. This we have already seen. Okay, I told you that this is your input stream, this is your input data stream. Okay, so if you have an input data stream, for example 0 1 1 0 0, okay, so basically it's like something like this. Okay, so you have something like this. Now if this is your input data stream, then you can notice if this will pass through serial input serial output shift register, then this will be as it is. Okay, there will be no change, but there is a delay. Okay, so there is no change, but there is a delay. I told you this is like, okay, so you are getting a delay here. Okay, this pulse will not change. Okay, this pulse will be same as it is, but you are getting a delay. Okay, so this is basically this delaying the pulse. I can say this is delaying the input pulse. This is delaying the input pulse. Okay, so this is the idea. So I can say a pulse train can be delayed by, okay, some clock periods. Okay, that is the application of serial input serial output shift register. So here the answer will be option A. Okay, so this we have already seen. Okay,